Okay, this lesson is on the chain rule combined with the product rule. So our learning goals are to learn to differentiate complex functions that require a combination of more than one rule. And we're learning to simplify the derivative so that it's expressed in simplified factored form. And this is going to be some intense algebra. And we'll go through it carefully, so hopefully you'll all feel confident doing it. So the chain rule can be used in combination with the product rule to differentiate complex functions. So our first example is to find the derivative in simplified factored form. You can see our function is y equals x squared plus 1 all cubed times 2 minus 3x all to the fourth. So we see it's a product of two power functions, so we're going to use the product rule. And I'm going to make my chart up here where I find the derivative of each function and simplify it as much as possible. So the derivative using the chain rule for the first is going to be 3 times x squared plus 1 squared times 2x equals 6x times x squared plus 1 squared. And the second one, 4 times 2 minus 3x cubed times negative 3. Don't forget the inner derivative. It's a common mistake, especially when you're just learning, or even just if you slip for a second. I've done it before, so just make sure you always remember when you're using the chain rule to multiply by the inner derivative. Now we're using the product rule. So that says we're going to do the derivative of the first times the second. So I'm looking for any monomial term first in the two terms that I'm multiplying together. 6x is monomial, so I'm going to put it out front. Then x squared plus 1 squared times 2 minus 3x to the fourth. So derivative of the first times the second plus the first times the derivative of the second, so these two. I'm multiplying together. Now when I'm multiplying together, it doesn't matter the order I multiply them in. So I'm going to put my monomial term first, and because we're adding negative 12, we're really subtracting. So there's my monomial negative 12. Multiplying by my binomials, doesn't matter what order I put them in here. 2 minus 3x cubed times x squared plus 1 cubed. So that's the calculus right there. I've just found the derivative using the product rule combined with the chain rule. But now I have to do this, I have to rewrite it so that it's in simplified factored form. So it's simplified as much as possible. So to do that, we have to use some factoring skills, exponent rules, both. So when you look at this first big chunk here is one term made up of three pieces multiplying together, and this would be my second big chunk here, or scoops I call them. There's 2 scoops there. And I want to find the greatest common factor. So I'm going to compare the monomials in each part first. So the 6x and the negative 12 have 6 in common. And then I'm looking at the x squared plus 1 to the power of 2 and the x squared plus 1 to the power of 3. Okay? So as in when you're finding the greatest common factor, even if it's a binomial common factor, you take the one with the smallest exponent, so it's going to be x squared plus 1 to the power of 2, because power of 2 is smaller than the power of 3. And then I'm going to compare the 2 minus 3x terms. Smaller exponent is to the power of 3. So this is my greatest common factor. And now I have to figure out what goes in the brackets. So I'm going to show you this kind of on another piece of paper. So what I'm really doing is, by common factoring, is I'm taking this first chunk here and to figure out what goes, the first part that goes in the brackets, I'm going to divide by the common factor. So my common factor is 6 times x squared plus 1 squared times 2 minus 3x cubed. So 6 divided by 6 is 1. So there's still going to be the x there. X squared plus 1 squared divided by itself is 1 again. Now I'm dividing powers with the same base. So if I just look at this part here, 2 minus 3x to the 4th divided by 2 minus 3x to the power of 3, you're dividing powers with the same base, so you keep the base and subtract the exponents. 4 minus 3 is 1. So when I divide these, I'm left with x times 2 minus 3x to the power of 1, which I don't need to show. Okay, so I've taken the first chunk and divided by the common factor. Now I'm going to take the second chunk, negative 12 times 2 minus 3x cubed times x squared plus 1 cubed, and divide it by the greatest common factor. 6 times x squared plus 1 squared times 2 minus 3x cubed. So negative 12 divided by 6 is negative 2. 2 minus 3x cubed divided by itself gives me 1. And then I'm dividing powers with the same base again. X squared plus 1 to the power of 3 divided by x squared plus 1 to the power of 2 is just x squared plus 1 to the power of 1. Okay, so now I have determined the greatest common factor of these two big scoops here, and then I've common factored this expression, okay? And I'm putting it again in simplified factored form. So right now, if you look at this first step here, not factored. We have two big things subtracting each other. Factored means your final answer will have everything multiplying, okay? Everything will be multiplying. So now you can see I've got everything multiplying at 6 times a bracket times a bracket times a bracket, but within here isn't simplified yet. So I can keep going because it's simplified factored form that I'm looking for. And then I can distribute here. So 2x minus 3x squared, and I can distribute there as well, minus 2x squared minus 2. And then in here, so I'm going to collect my like terms, negative 5x squared plus 2x minus 2. Oops. Okay. So the last thing that I would do then is check to see if what was in here could be factored. It would be a complex trinomial, but in this case it can't be factored. There aren't two numbers that multiply to positive 10 and add to 2. So we're done at this point. And it is in simplified factored form. Okay, next question. B. F at x equals 7x squared times 8 minus 5x cubed all to the 5th. So again, it's a product rule. There's my first, there's my second. So I'm going to do my chart over here. So my first is 7x squared, and the second function is 8 minus 5x cubed to the 5th. The derivative of the first is 14x, and the derivative of the second is going to be 5 times 8 minus 5x cubed to the 4th, then times the inner derivative, which is going to be negative 15x squared. And then I can multiply those together to give me negative 75x squared times 8 minus 5x cubed all to the 4th. So you're setting it up now to use the product rule. So f prime at x, derivative of the first times the second, look for a monomial term. If there is one, you want that first. So 14x times 8 minus 5x cubed to the 5th. And then here we have a monomial and then another monomial. So I can multiply those two together. So I can do 7 times negative 75 gives me negative 525 x to the 4th times 8 minus 5x cubed to the 4th. And that was because 7x squared times negative 75x squared was negative 525x to the 4th. Okay? All right, so now that's our derivative. We've done the calculus part. The rest of it is to put it into simplified factored form, so that's algebra now. So the first thing we're going to do is look at the two scoops and figure out what the greatest common factor is. So do 14 and 520, or yeah, negative 525 have a number in common? Well, I can see here that to get 525, I did 7 times 75, and I know 7 goes into 14, so 7 should be in common. And then I've got an x and an x to the 4th, so x is in common, lower exponent. And then I've got my 8 minus 5x cubed to the smaller power, which is the 4th. So now I need to find out what goes in the brackets. So I'm going to take my first chunk, 14x times 8 minus 5x cubed to the 5th, and divide by 7x, my greatest common factor, 8 minus 5x cubed to the 4th. 14 divided by 7 is 2, x divided by x is 1, 8 minus 5x cubed to the 5th divided by 8 minus 5x cubed to the 4th is just 8 minus 5x cubed. So that goes in my bracket first. Okay, so now I'm going to divide the second chunk, negative 525 x to the 4th times 8 minus 5x cubed to the 4th divided by 7x, my greatest common factor, 8 minus 5x cubed to the 4th. So negative 525 divided by 7 is negative 75. X to the 4th divided by x is x cubed. And these are exactly the same. Both to the 4th power, they divide to give me 1. So minus 75x cubed. So now I've got it in factored form, but not simplified factored form. So I'm going to keep going here. 7x times 8 minus 5x cubed to the 4th times, so distribute there, 16 minus 10x cubed minus 75x cubed. And that's going to give me 16 minus 85x cubed. And then I would check and see if that can be factored, but there's nothing in common with 16 and 85. So there I've done, I have it in simplified factored form. Next one, y equals x times x squared plus 1, or sorry, square root of x squared plus 1. So first I'm going to rewrite it in exponential form, and I see it's a product rule. So here's my one function of x multiplying by my other function of x. So I'm going to do my first, second function derivative. My first function is x. Second is x squared plus 1 to the half. Derivative of x is 1. Derivative of x squared plus 1 to the half is a half times x squared plus 1 to the negative 1/2, then times the inner derivative, 2x. So product rule, y prime, derivative of the first times the second is just going to be x squared plus 1 to the half. Oh, here I didn't simplify. I should have done that first. So half times 2x is just x. Make sure you do that so it's easier. So now I'm really multiplying these two together. So I'm looking for monomials. So I've got my monomials here I can multiply together. So plus x squared times x squared plus 1 to the negative 1/2. So there's the calculus. That's the derivative right there, but now we want it in simplified factored form. So here's my first scoop, and there's my second one. And we're looking for the greatest common factor. So we see that both of them have x squared plus 1 binomial in common. And the smaller exponent is the exponent negative 1/2. So that's my common factor. So there's my common factor. So now I'm going to divide the first scoop by the common factor. And look at how nice this works out. So using exponent rules, I keep the base and subtract the exponent. So 1/2 minus negative 1/2 is the same as 1/2 plus 1/2, which is 1. So when you common factor out x squared plus 1 to the negative 1/2 into the first term, you're just left with x squared plus 1. With the second term, so if I'm dividing x squared times x squared plus 1 to the negative 1/2, and I'm dividing by x squared plus 1 to the negative 1/2, these cancel, and I'm just left with plus x squared. So y prime is, so I'm going to move this to the bottom because it has a negative exponent and make it x squared plus 1 to the positive 1/2. And then here I'm going to collect the like terms, 2x squared plus 1. I would factor the 2x squared plus 1 if I could, but it's not factorable, so I'll just leave it. And here I started off with a radical form, so I'm going to end up writing my final solution with a radical form as well. So there would be my final solution in simplified factored form. D, h at x equals x plus 1 times the square root of x squared plus 2x plus 2. So again, I've got my two functions. First, I'm going to rewrite them. So I'm going to rewrite the second function as x squared plus 2x plus 2 to the 1/2, and then make my chart. So first, second, function, derivative. So my first function is x plus 1, and the derivative is 1. My second one is x squared plus 2x plus 2 to the 1/2, and the derivative is going to be 1/2 times x squared plus 2x plus 2 to the negative 1/2 times, so inner derivative is going to be 2x plus 2. Now, if I multiply, let me just rewrite this first. I'm going to put the 1/2 and then the 2x plus 2, and then the x squared plus 2x plus 2 to the negative 1/2. Because what you'll see is you can distribute this 1/2 in here. So I get rid of this fraction 1/2, and I end up getting 1/2 times 2x is x, and 1/2 times positive 2 is positive 1. Doesn't always work out so nicely, but in the case where it does, as again, simplify as much as possible in your chart, so it's easier when you go to use the product rule. Okay, so now we're going to use the product rule. So h prime at x is the derivative of the first times the second. So it's just going to be x squared plus 2x plus 2 to the 1/2 plus the first times the derivative of the second, and I can see I've got an x plus 1 times another x plus 1, so that's going to be x plus 1 squared times x squared plus 2x plus 2 to the negative 1/2. So there's my calculus again, that's the derivative, but we want to put it in simplified factored form. So I'm going to look at my two scoops here and decide what the greatest common factor, what's in common in both scoops, is. And that's going to be the x squared plus 2x plus 2 with the smaller exponent negative 1/2. And again, I'll show this. Hopefully you're starting to get used to it. So I'm going to take the first scoop, x squared plus 2x plus 2 to the half, and divide that by x squared plus 2x plus 2 to the negative 1/2, which is my greatest common factor. So I'm common factoring there, which I'm going to keep the base and subtract the exponents, which gives me x squared plus 2x plus 2 to the 1. Okay, so when I divide these, I just get x squared plus 2x plus 2. Plus, when I divide this big chunk by the greatest common factor, these will divide out, they're exactly the same, so I'll just be left with x plus 1 squared. So now it's in factored form, but we have to simplify it still. And in order to do that in here, I'm going to have to expand and simplify the x plus 1 squared. If you can square the binomial in your head, you're going to get x squared plus 2x plus 1. I'm going to move this negative exponent, I'm going to move it to the denominator so the exponent can become positive. Collect like terms here, so x squared plus x squared is 2x squared. Positive 2x plus 2x is plus 4x. Plus 2 plus 1 is plus 3. See if the numerator can be factored. There isn't a common factor. If it were a complex trinomial, I'd need numbers that multiplied to 6 and added to 4. And there aren't any, so that can't be simplified any further. And then I'll rewrite the denominator with a radical. So the square root of x squared plus 2x plus 2. So there's your final answer in simplified factored form. Find the equation of the tangent line to the curve at the point -1, -9. So notice how it doesn't say to find the solution in simplified factored form. You don't have to. In questions like this where you're finding the slope of the tangent, which we need in order to get the equation of the tangent line, you can decide how much simplifying you want to do before you substitute in x equals -1 to find the slope of the tangent. But we should recognize that this is product rule because it's the product of x to the 4th minus x plus 1 all squared times x squared minus 2 cubed. And I also need to do the chain rule inside the product rule here. So I need my two functions as well as their derivatives. So the derivative of the first to the 1, and then the inner derivative is 4x cubed minus 1. And then here, the derivative is 3 times x squared minus 2 squared times 2x. And I can combine those and make 6x times x squared minus 2 squared. Okay, so now I'm going to find y prime using the product rule. So derivative of the first times the second, monomial term first. Plus the first times the derivative of the second. I'm going to put the monomial first. So there I've got the derivative. At this point, it would be your choice. You could definitely just substitute. You could find y prime at -1 right now and just be really careful substituting in because there's so many places to sub -1 into. Or if you want to, I'm just going to simplify it because that's what we're practicing doing. But here's my 2 scoops. So I'm looking at the 2 and 6x, 2's in common, x to the 4th minus x plus 1 to the 1 and to the 2 to the 1 is in common. 4x cubed minus 1 is not in common, so it can't be part of my common factor. And then x squared minus 2 to the power of 2. So if I divide this first scoop by the greatest common factor, the 2's cancel, these cancel. I'm left with 4x cubed minus 1 times 1x squared minus 2 here, plus, divide my second chunk by the greatest common factor, 6x divided by 2 is 3, x squared minus 2 squared divided by itself, and I'm left with one of these, x to the 4th minus x plus 1's. And I'll continue simplifying here. So I'm going to need to do FOIL. Be careful, so 4x to the 5th minus 8x cubed minus x squared plus 2 plus 3x to the 4th minus 3x plus 3. See if there's any like terms in here. So 4x to the 5th plus 3x to the 4th. I'll just put it in descending powers of x here. Minus 8x cubed minus x squared minus 3x plus 5. I don't know that I made it that much simpler. And now we're going to substitute in -1 because we want the slope of the tangent. So be careful. So that's -1 to the 4th minus -1 plus 1 times -1 squared minus 2 squared times 4 times -1 to the 5th plus 3 times -1 to the 4th minus 8 times -1 cubed minus -1 squared minus, minus 3 times -1 plus 5. Y prime at -1 is 2 times, so that's going to be +1 plus 1 plus 1 times 1 minus 2 is -1 squared times, so that's going to be -1 times 4 is -4 plus 3. -1 times -8 is +8 minus 1 plus 3 plus 5. So that's 2 times 3 times 1 times, so it's -1 plus 8 is 7, minus 1 is 6, 9, 14. So y prime at -1 is 6 times 14, 84. So we know M tangent is 84, and we also know we have the point -1, -9. So we can use y equals mx plus b to find the b and then get the equation of the tangent line. negative 9 equals 84 times negative 1 plus b. B equals 75. So therefore, the equation of the tangent line to the curve y equals x to the fourth minus x plus 1 squared times x squared minus 2 cubed is y equals 84x plus 75 at the point -1, -9. Okay, so that lesson was on combining the chain rule and product rule to write the derivative in simplified factored form. All right.